last time we basically did vector triangle. I hope you have solved some of those which I gave you the homework. Today we are going to start with resolution. Okay. If you guys have any questions, do let me know. Okay.
Sir, I had some questions that I sent you on Skype.
Okay. All right. Let me see.
Yeah, I sent you on the private.
From the worksheet.
Yes, from the worksheet.
These are the old ones. Okay. All right, so after the class, I'll tell you. All right. Now,
Okay, sir. No problem.
so speaking of resolution, then, so any vector that you see could be of three types. All right. So you could have a vector which is on the, like it could be on the right or left. It could be up or down. So horizontals could be like that, verticals could be up and down. Now, then you have vectors that are at an angle, like this, or this, or this, or this. So it could always be like that as well. Now, so few things that we need to basically learn before we get into this are some of the math rules. And the math rules are that since, if you look at a triangle, so if they're 90 degrees, so this is the vertical, this is the horizontal. Basically, you can call this as opposite, this as adjacent, and this is the hypotenuse, and this is the angle theta. So with respect to that, we can say that the cosine theta is equal to the adjacent over hypotenuse. Sine theta is opposite over hypotenuse, and tan theta is opposite over adjacent, like that. So generally, in resolution basically means that we are going to break down the vectors into horizontal and vertical components. Okay. Now, so for example, if we have a vector like this and we're like, okay, we want to break it down. So what you're going to do is you're going to make two components such that one has to be like this and the other has to be like this. So the vector that is this one, that is the original vector that we've broken into its vertical and horizontal component, must be somewhere in the middle of these two, and angle theta is given here. Now, if you notice, the adjacent side is always next to the angle in this, and the hypotenuse is next to the angle as well, whereas opposite isn't, which means this side that you see right now is next to this angle. So this makes it the adjacent, and this makes it the opposite, and this makes it the hypotenuse. So right now, if I want to find adjacent, I need to multiply hypotenuse with cos theta, because f is hypotenuse. So I'll write this component as f cosine of theta. The easy way to remember is that whenever you see a component next to the angle, it will always be the vector, original vector multiplied by cos theta. And then the opposite would be f sine theta, because you can find opposite by multiplying the hypotenuse with sine theta. Is that clear, everyone?
Yes.
Okay. All right. Hello, Hatija, Dania, Hiba, Ahmad. Ayan, Aman, Bassam. Okay. Now, so speaking of that, then, suppose the angle is given with the vertical. So obviously, the vertical will be like this component, and the horizontal will be like that. And if this is the case, you see the angle is next to this vector, which means this makes it f of cosine theta, because this is the adjacent one, and that would be the opposite one. So it's going to be f sine theta. So it's basically the angle that decides. So angle decides which is sine theta, which is cos theta. So the one that is always next to the angle will be cos theta. So you should remember that. Any questions, please let me know. All right, now, so the very first thing you're going to do is that you need to learn how to break vectors, right? So for example, in this example, you might see 35. So one side will be to the left, because it is basically somewhere, like this, where one component will be towards the right and the other will be up. So if I want to find the values for it, so let's call this vertical, let's call this horizontal. So for horizontal, it is going to be 35 cosine of 57, because it is right next to the angle. And then the answer will be 19.1 meters per second. This vector, vertical one, it will be 35 sine of 57. That's going to be 29.4 meters per second. Similarly, if you look at this, so obviously when you make one vector, it's in this way because one vector has to be towards the left and one down. So this is the horizontal and this is the vertical. So you can say that this is the horizontal is going to be 12 cosine of 34, which makes it 10. And the vertical is going to be 12 sine of 34, which is going to make it as 7 meters per second, just like that. Do let me know if you find difficulty anytime. Okay. Now, the last
Can you
one.
give time to copy?
Yes, please. You can copy. All right. So today, I think the only new kid is Emma disease, right? Yeah. Okay. Ahmed, Ahmed, are you there?
Yes, yes,
सर
I'm
वही
here.
वापस आ गया.
Ahmed, you need to join the Google Classroom link. All right. There will be there is a file in the Google Drive, and that Drive file you need to download for scalar and vectors, and then you need to print it out. You can do it later though, and then fill it up, whatever you're doing. Okay, that's fine. Anyway.
Sir?
Hmm.
Sir, for example, the V is pointing downwards, so will it affect like positive or negative, something like that?
It does, but right now we're not looking at that. Okay, we will look at that. We will look at that when we have multiple vectors. Okay.
Okay.
Anyway, so now in the next one, we could draw one vector down and one vector to the right. So this will be basically horizontal, vertical, horizontal. So this time horizontal is not next to the angle, so it makes it 20. Sine of 30. And then basically it's 10. And vertical is going to be 20 cosine of 30. The reason is it is next to the angle, as you can see. So it is going to be 17.3 meters per second, like that. Okay. Now, so suppose then sometimes the components are given and they expect you to basically draw the resultant, find the angle, whatever. And they also expect you to basically find the value. So in this case, if there are two components like up and right, so obviously the resultant has to be somewhere in the middle. And then if it's going like down and left, somewhere in the middle then. Okay, like that. And then for this one, right and down, it will be somewhere in the middle as well. So right now what they've said is they want to find this angle theta, which is from the horizontal. And they also want you to find the value of the resultant. Let's call this f.
Sir, wait. How do you
Yes,
know the angle?
they've written find resultant vector angle from horizontal.
Oh,
Okay, so
yes, okay.
now, so finding the resultant is super easy. What you can do is you can use the Pythagoras theorem. For Pythagoras theorem, you just need to do to find f.
Sir,
You need
just
yes,
take a photo. Very good.
yes, why not?
Okay, you can go now.
Ayan, have you submitted the previous work?
Yes, I have, sir.
Okay, very good. So horizontal square plus vertical square under root, that will give you the answer basically. It's very simple. What you're going to do is 5.7 whole square plus 3.4 whole square under root, and that's going to give you 6.64. Okay. And now if you want to find this angle, you should know this is the adjacent side and this is the opposite side. So you can simply use tan theta, and tan theta makes opposite over adjacent, and then you can take tan inverse, which is going to be 30.8 degrees, like that. So it's pretty simple. Then comes the other thing, where here you can do the same thing. You can take 10 squared plus 3 squared and take the under root, Pythagoras theorem, and then this is going to be 10.4. And then when you find the tan theta, is going to be basically opposite, which is 3. It's not next to the angle, divided by 10. And when you take the tan inverse, it's going to be 16.7 degrees, like that. Finally, this is also super easy. You just need to do 20 squared plus 12 squared under root. And then what you want to do is, this is going to be 23.3. And tan theta is going to be opposite this time is 20 divided by adjacent is 12. And when you take tan inverse of this, you get 59 degrees, like that. So combining is super easy. All you need to do is, just use Pythagoras and tan theta. So you can copy this down if you want to. Okay, cool. So Hale,
Yes, sir.
nothing. All right, done. Anyway, now going to the next one. let's look at a full question and see how it is solved using resolution. Okay. So suppose that this question has come in your exam, and in this question, as you can see, there's a tire hanging. There's 150, 150, and 17 from that. It says a child swing is made by connecting a car tire to the wire using a rope and a hook. The system is in equilibrium with the wire hanging at 17 degrees. The tension in the wire is 150 so to determine the weight. So what they want is they want to find the weight, okay, of this. But we should also understand that actually whatever the weight of this tire is, it is in equilibrium, which means that the wires are carrying the same force and balancing it. Is that clear, everyone?
Yes.
Yes.
So remember this word, this is very important. And if this comes, you should remember that all forces are balanced. And when it is balanced, it means that in this case, weight will be equal to the upward force. Okay, whatever we want to call it, I will just want to call it up because it's the same. Anyway, now think about it. So first of all, what I'm going to do is, there are two ways of really doing this. What you can do is you can make a small graph on the side. Although I don't prefer this, because when you learn how to solve vectors, it is just another step that adds to your time. So I don't want to, do that. But still, for beginners, you should remember that if you take this side as positive, right, to the right, then all the vectors to the left should be negative. And if you take upwards as positive, all the vectors to the to down is also negative. Now you can switch them, like you want to take negative bottom and positive top. That's up to you. So it doesn't really matter. But right now, if you look at this vector only, this angle, you realize it's 17 degrees. So basically, this is the same angle which I can draw here. Can I do that, please? It's alternating angle, right? And also for this vector, I can draw the same angle here, which is 17 degrees. Now, check this out. One vector is like this, which is of 150 newtons, this one. And it is at 17 degrees from the horizontal, and the other vector is like this, which is also 150 newtons. And it is also 17 degrees from here. Now, what happens is that this helps us, quickly see where the components are going to be. Okay. Now, for example, I'm going to call this one as this vector is A, this vector is B, and make a small table here. Write A, like B, write horizontal and vertical like this. Okay, like that. So for the very first one, which is A, you might see that one of its components are or should be like this and like this. So the horizontal component of 150 should be called 150 cosine of 17. And because it is towards the positive side, I'm going to put a positive sign here. Everybody agrees?
Yes.
Now, for the same vertical one, which is here, it is going to be 150. Let's think. Okay. So it's just a second, please. Okay. So it's going to be 150 and sine of 17. Can you tell me should I put a positive sign or negative sign here? Anyone?
Positive.
Yeah.
For
Because
B,
it is upwards. Yeah, for A. Yeah, B. The vertical one for the vector A is upwards. So it's just, I've taken it positive. So I'll just put a positive sign. Then what I'm going to do is I'm also going to break the other vector, which is B. For B, if you notice, one vector is like this and the other vector is like this. So this one is going to be 150 cosine of 17. Okay. Can you tell me if there's a mistake here?
Minus.
Yes, because it is towards the left and I've taken negative at the left. So you should remember that towards the left, so it should be negative here. And then for the vertical one, it's upwards. I'm going to use 150 sine of 17. And obviously this has to be positive because it's upwards. Once you've done this, no matter how many vectors.
Or it has to be sine. Oh my bad.
Okay. Now, so what you're going to do is, once you've done this, no matter how many vectors they've given, so you can always do this, and then you have to sum it up. So if I take the sum of this, so plus 150 cos and minus 150 cos will be 0. And this one, you can take out the calculator, just simply, solve it. Okay, I'm sorry about that. So what you get, 150 sine of 17 plus 150 sine of 17. So this is going to be about 87.7. So I get 87.7 newtons as my answer for this. Now, well, the next logical step is that once you've taken this, you can obviously take the Pythagoras theorem, and the resultant of this is going to be obviously 0 square plus 87.7 square. Even if you don't take it, if one component 0, obviously the answer will be the same. So it is going to be 87.7 newtons. Now, so this means that the resultant of these two are acting vertically, and if this is 87.7 newtons, then obviously weight is the same. So I'm just going to write this answer. Now, because my answers were two significant figures and my data was too significant, so either I'm going to write this like 87.7 or I could get away with 90. Now, what most of the people do is they do this in the exam as well. So when I've written or, it means or. It doesn't mean that you have to write both of them like this. So you can either pick this or this. Do not write both of them, please. All right, is that clear, everyone?
Yes.
Sir, on the horizontal side, how are you getting 0? You cancel out the both. That's how you get it.
Yeah, it got cancelled automatically. I didn't cancel it. I just applied the signs.
Okay, fine. Got it.
And that basically makes sense as well. If you realize the wires are lifting the weight, which is vertically down, right? So the resultant has to be vertically up. That's the way it's balancing, right? So on the sides, it's not swaying on the sides. It means nothing could be on the side. That's why the horizontal components are cancelled out automatically. Do you get my point?
Oh, yes, sir.
Okay. All right. Aman, Khatijas, both Khatijas, Hamad, Basam, Zan. Do you guys understand? And
Yes, sir.
Hiba?
Yes, sir.
Zan?
Yes, sir.
And okay. Hamid? Okay. Good. Very good. Suhail, is it clear? Should I go forward now?
Yes.
Now, so then let's talk about this question. Okay. Now I gave this as didn't I give this? No, I didn't give this as homework. That's fine. So who can tell me what is vector scalar quantity? Well, I shouldn't be asking this, but anyone. What is scalar, please?
So scalar is only magnitude but no direction.
Okay, only magnitude.
And vector has both magnitude and direction.
Direction. Okay. And vector has magnitude and a specific direction. All right. So the next thing is this one. Can somebody please tell me power is a vector scalar?
Scalar.
Scalar.
Scalar, very good. And temperature? Is it
Scalar.
vector scalar? And momentum?
Vector.
Vector.
Okay, so you already scored 4 marks. That's really nice. But the real question starts from here. Now, so in this question, it says an aircraft is traveling in wind. Okay, and there are like two vectors right now. and they've also given the angle. So you should always remember that the horizontal one doesn't have the angle, but basically this vector has the angle, which is obviously, if I draw a horizontal line, it means this angle is the same as this one, which is 65 degrees. All right, let me write it here. Okay, now, so then it says draw an arrow labeled R in the direction of resultant force. Obviously, if you realize this, that if something pushes you to this side and something pushes you, so obviously you're gonna go somewhere in the middle, right? Between them, all right? So this is what you're going to do. Okay. So now, fine. Anyway, speaking of this then it says determine the magnitude of resultant force. So we got to do that. Usually these kind of questions are easier with vector triangle, but we can always use this method as well. So again, if you want to, you can draw oh my goodness, sorry. If you want to, you can draw the free body diagram like that. And then you can say, all right, if you look at this, you can say this is positive, this is negative. I can take this as positive, this is negative. And if you look at the aircraft velocity, it is already horizontal like that. And the value of this is 95. And then if you look at the other one, which is this velocity, you can just keep the tail at the center. It is like this. So that's 28. And the angle of this is 65, right? Now, so we're done with that. Other way, if you really want to, do it quickly, I'm also gonna do that. So what you can do is, you can actually, let me make the resultant again. It's not there, sorry. Okay, so what you can do is you can make two components like this one and this one, obviously. And you can call this as positive, this is negative, upwards is positive, negative. And this has no components. And now let's call this A, let's call this vector B, and draw a small table. So you can say this is horizontal, this is vertical. So for A, you should understand that it's completely horizontal and it has no vertical components, which means you're going to write 95. And then because we took left side as negative, we'll put a negative sign here. And for the vertical one, it has no vertical component because it is completely horizontal. All right, so you should remember that. Now, for B, the horizontal component, because this was the angle is 65, so you should understand that this is next to the angle, so this is going to be 28. Cosine of 65, so I'm going to write 28. Cosine of 65, and then because it is towards the left side as well, I'm going to put a negative sign, and upwards is positive, so I'm going to write 28 sine of 65. Please let me know if you do not understand this.
How did you draw the? Did you use the resolution method?
Sorry?
Did you use the resolution method? So the line that they wrote as velocity.
No, basically what I did was, you see, I did not put them here because it takes a lot of time. What I did was, one vector is like this, right? 95. You agree?
Yes.
And one vector is like this, which is 28. So this angle is 65. I took this component and this component. So, and then I separately add them directly instead of putting on the graph. Do you understand?
Yes.
So you can always go back to this method if you want to, because it will take a little bit of time. If you don't want to do it on the papers, usually take a pencil to do it. So once you've done this, and then what you're going to do is,
Which one did you mention? Which one did you write 28 is? Is it the one which is vertical, the one which is diagonal?
so I didn't get your question. Can you come again, please?
That one is labeled as 28. Is it one which is vertical or the one which is like diagonal?
Diagonal. They said it's 28. You see?
Okay.
Okay, so please wake up. All right, now. So now you're going to take the sum of this, and then when you take the sum, it's pretty simple. Let me take the calculator out. So it's going to be 95, sorry, negative 95 and negative 28 cosine of 65.
Minus 106.8.
Yeah, so it's going to be minus 106.8. Very nice. Very nice. Very nice. Just let it roll. Minus 106.8. And the other one, we can just simply do
11.8.
Okay, 11.8. Thank you. It's 11.8. Now, the next thing we're going to do is we're going to simply use the Pythagoras theorem. So for the resultant, it's going to be minus 106.8 whole squared plus 11.8 whole squared under root.
109.24.
Okay, 109.24. So now, again, if you look at them, this is two significant figure. This is also two significant figures. So I want to write it ideally in 2 or 3. So my answer should be like 110, or it should be 109 meters per second. All right, so both are acceptable as long as you follow the rules. If you have any questions, please let me know.
Sir, I didn't understand how you got R, the direction of R.
Direction of R. I never found the direction of R.
No, like I, part I.
Oh, you didn't understand that. Okay, let me just tell you how. So, so what I've done is, so imagine this, please. Liber, this velocity, the wind is going to push whatever it is to this side. You agree?
Yeah.
Let me just draw it nicely to this side. And the aircraft velocity in still air is basically pushing it to this side. Don't you think?
Yeah.
So then, if there are two vectors, one on this side, one on this side, where would the aircraft go? Somewhere in the middle, right?
Yeah.
So that has to be the resultant then. Do you understand?
Okay. So it shouldn't be any exact angle?
No, they said draw an arrow in the direction of the resultant velocity. You shouldn't, like, you just need to draw an arrow. All right.
Okay.
Generally, you should understand that because, oh my goodness, wait a second. I accidentally did that. So generally, basically, you should understand that the vector that is bigger, like in this 95 was bigger, right? Okay,
Sir, you still on sharing the screen?
it is going to come up. Okay, you see now?
Yeah.
So generally, if you see that this vector is bigger, 95, so obviously there will be a greater impact of this vector, which means it's going to be closer to the west than to the north. Understood?
Yeah. Thank you.
Generally, it's like that. But with that, he's just going to maybe a little bit be relaxed because you already know that, all right, these would be the resultants. All right. Is that clear, Naiba?
Yeah, sir.
Okay. Now, so then I wanted to solve this question now. I'll do this. And then let's go forward. So distinguish between vector and scalar quantities. You all
Sorry, a
yes,
photon was.
yes, I am. Yes, go ahead. All right, you guys please copy this. I'll be back in just 30 seconds. All right, done. Okay, now going forward. So in this question, it says distinguish between vector and scalar quantities. Obviously, you can write vector has a magnitude and direction. Scalar has only magnitude. So you can always write this. And then it says determine whether each of the following is. Temperature is definitely scalar. Acceleration is vector. And electrical resistance is scalar. So you should know that. That is on the list as well. Now, this question is quite interesting, and I would like to discuss it. Now, in this question, it says a block of water weight 25 newtons is held stationary. If it is held stationary, that means this is in equilibrium. And equilibrium means that all forces are balanced. So just want to tell you, we will study this in future as well, but I just want to tell you, whenever something is in equilibrium, it could have two different states. One, it could be at rest, or it could be moving with constant velocity. So there has to be, the acceleration should be zero. That is what it means, okay? Now, speaking of that, then it says this diagram, and it says the tension the string is T and the slope pushes on with the force of R, that is normal to the slope, and 35 degrees. Either by scale drawing, calculation, or determine the tension in the string that there is. All right. Now, so right now, the slope is like this. So what I'm going to do is, I'm going to create some of the components here. So if you look at this, we can say that this weight will have two components according to this slope now. One component is going to be vertically, like perpendicular to the slope. That's always the case. And the other component of the weight is going to be parallel to slope. And interesting thing about this is always down the slope. So wherever down is, and always like this. Now, according to this, then, if this is 35, then obviously this angle will also be 35 because they're like alternate angles. Because this angle is next to it, this makes it W cosine of 35, and this makes it W sine of 35. Now it's up to you what you're going to do. You see, when you've resolved this, you just need to look at things which are in the similar direction. Like, for example, if I take this side as positive, this side as negative, because why we are doing this, like why we have to take it on the slope, because now our reference line is slanted, so we just take it on the slope. Let's take this as positive, this as negative, and this as positive, and this is negative, right? So if I do that, then this makes it, this is positive, this is negative, this is positive. This makes it to be negative, and this is also negative. Now, think about this. So now, for the horizontal direction, I have like parallel to the slope, sorry. Parallel to slope, you have positive t and negative w sine of 35, which is this. And because it is in equilibrium, which means the net result of all of these has to be equal to 0. Or you can simply, put it together like that. So now the weight is 25 and sine 35. You can simply use the calculator to do that. Obviously, when I'm explaining, I just need to explain in detail. You can, in the exam, if you already know that they're equal, so you can put them equal directly. You don't have to do the extra steps and save some time. So this,
14.33.
yeah, so it's going to be 14.33. All right. And in case the examiner asks you to find this r as well, so you can always find perpendicular to slope, and this will be plus r negative w cosine of 35, and obviously this will be 0 as well because it is in equilibrium. So r will be 25 cosine of 35. Zahan, what that might be?
20.47.
20.47.
20.48.
Okay. 20.48, which is just 20.5. Okay. Anyway, so now in the question it says give the tension T. So you don't need R, you just write 14.3.
Can you go up a little? I want to take screenshot.
Yes, please. All right, you guys can copy this, and if you have any questions, please let me know.
Okay, sir.
Ahmad, Laiba, Suhail, Khatija, squares, and Haiba. Do you guys understand this?
Yes, sir.
Yes.
Dania, Ayan, Aman. Question, please. Okay, very nice. Okay. Yes. All right. So now So this is what we've done. I hope you guys understand this. And yeah, all right. I know where's the rest of it. Okay, so now for the homework, you should be able to do this question. This is for homework. You got to do it with the resolution. And you got to do this with resolution as well, because this is 3 forces. You can't do it otherwise. And then the last one is also with respect to, this I wanted to do this with you. All right, I'll do this, please. All right. Now, speaking of this question, the last one, it says, two physical quantities P and Q are added. The sum of P and Q are R. And it says which quantity could be represented by P and Q. Now, first of all, I just want to tell you that all these quantities, some are vector, some are scalar. Can you please tell me which could be the vector in this?
Velocity.
So that is the answer. Because if they were scalars, then they wouldn't have any direction. And if they do not have the direction, we can't just make vectors out of it. So only vector quantities can be added like this. Scalar quantities, we simply add or subtract. There is no direction to this. That is the question. So I just wanted to share you that some questions are pretty easy. Just look a bit different. All right. So don't worry about that. All right. If there's any question, let me know. Otherwise, you guys can now